Section 12.2, Frequency Distributions and Statistical Graphs. In this section, we're going to be able to learn about constructing frequency distributions, interpreting histograms, frequency polygons, stem and leaf displays, understand circle graphs. So let's talk about frequency distribution. A piece of data is a single response to an experiment. A frequency distribution is a listing of the observed values and the corresponding frequency of occurrence of each of the values. Here's an example. The number of children per family is recorded for 64 families who were surveyed. Construct a frequency distribution of the following data. So here's the data that were collected from the 64 families, and it's difficult to really see what was the most common size of a family. But if we create a frequency distribution, we can summarize the data. And so we see on the left column the values. These are the numbers that we recorded from the families, and they range anywhere from 0 children up to 9 children. And in the right column, we have the numbers of families who answered that, so how many children were in their family. And notice that the frequencies have to add up to the total number of families surveyed. In this case, that's 64. So we notice 8 families had no children, 11 had 1 children, 18 had 2, and so forth. And again, I mentioned that notice that the sum of the frequencies has to add up to the original number of pieces of data, in this case 64. Here's a frequency distribution where each of the groupings is a range of values, and this is looking at income. And rather than having each of the values here in the left column be a single income level, we've grouped them together into what we call classes. And we see in this group there are 15 families that were surveyed. 2 families had an income between $31,000 and $37,600, and so forth. Now, the mode is the category or the class with the largest number of observations. And in this table, the modal class there runs from 43,900 to 50,000. How many families had incomes above 50,000? And that's going to be the last 3 classes here. And we see there were 5 families. A histogram is a graph with observed values on the horizontal axis and the frequencies on the vertical axis. Because histograms and other bar graphs are easy to interpret visually, they're used a great deal in newspapers and magazines and in online websites. To construct a histogram, and we're not really going to do construction of histogram in this class, but I'll let you read through the steps here. And I would urge you, if you're going to construct a histogram, to use some type of technology like Excel. So construct a histogram of the frequency distribution below that shows the height of persons in a group of 540 people. And the heights are grouped here from 4 to 5 feet, 5 to 6, 6 to 7, 7 to 8. And it's a multiple choice question. Now, what you want to look at, first of all, you want to look at the numbers of people here range from 20 up to 340. So the first thing I'm going to look at is along your y-axis, the frequencies that we're seeing here. In some cases, they're going up a lot higher than what we're seeing in our different classes up here. The largest number we see is 340, and that happens in the second grouping between 5 and 6 feet. And if we take a look, we can eliminate graph B because the highest category here, the modal class here, is in the third group, which is not correct, and that's also true on graph C. Now look at graph A, and if you notice that this second group is the highest, but you notice here, if you look at the scaling on the y-axis, it's actually much larger than 340 people. So the correct answer here has to be answer D. And you notice here, this goes up to the 340, and we say the first class is at 60, the third class at 120, and the last class, the smallest, is at 20. Use the histogram to answer the following questions. And let's look at what we're looking at. We're looking at the number of soft drinks that were purchased at a theater. And along the x-axis, we have the number of soft drinks purchased, which ranges from 0 to 6. And then in each grouping, we have the number of people that bought that many drinks. So let's just, for example, look at how many people bought no drinks. And we look over here and we see 3 people. Likewise, 3 people bought 1 drink, 7 people bought 2 drinks, and so forth. How many people were surveyed? Now, to find a total number of people who are surveyed, you want to look and see how many people were represented in each of the categories. So here we have 3 and 3 is 6, and we said this was a 7, so 7 and 6 is 13. Here we have a 4, 13 and 4 is 17, plus 3 is 20, looks like 22, plus 1 looks like 23 total people. And I did that by looking at the height of each of the bars. What is the modal class? Remember, the modal class is the one with the largest frequency, and that's going to be 2 drinks. How many people bought 4 soft drinks? So we look over here at 4, we look at the height of that bar, and it looks like it's 3 people. How many soft drinks were purchased? Now this is a little bit more complicated to calculate. You're going to have to look at the height of each bar, how many people bought that many drinks, and multiply it by the number of drinks represented by that bar. So for instance, 0 drinks, 3 people bought 0, so that means there's no drinks there. Here we have 3 people bought 1 drink, so that's 3. Here we have 2 times 7, 14, plus 3 gives us 17. Here we have 3 people bought, and there were 3 drinks bought by 4 people, that's 12, so we're up to 29. Here we have 4 drinks bought by 3 people, that's 12, that's 43. Here we have 5 drinks bought by 2 people, that looks like 53, and then 2 more drinks, so it looks like a total of 57. I'm sorry, this is 6 here. 57 total soft drinks were purchased. And again, I took the value of the numbers in each class times how much the class was worth, how many drinks. A frequency polygon or line graphs that scale is the same as a histogram. Basically what you do is you connect the center of the bars on the histogram, take the bars away, and then use the line graph. So here's the number of children per family. And again, frequency polygon starts at the x-axis and then goes to the first class, and there's a dot there to represent the height of it. And sometimes it's easier to read than the histogram to tell what the numbers are in each of the classes. So use this frequency polygon to answer the questions. How many families visited the zoo 4 times? So we look here at 4, we go up here and we see that must be 8 families. How many visited at least 6 times? So at least means 6 or more. So we look up here and we see 11, plus 9, 20, plus 3, 23, none here, so 1, 24. How many families were surveyed? So again, we have to have the total for each of the groupings. So we have 4, plus 2 is 6, and 8, and 8, 16, plus 6, 22, plus 6, 28. This was 11, so that's 39, plus 9, 48, plus 3, 52, I think it's 53, 52. 52 altogether. So again, I take the number represented of how many families were in each of the groupings here on the number of visits, and it should be 52. A stem and leaf is a tool that organizes and groups the data while maintaining the original data values that we see. And again, I'm going to suggest to you that you would use technology to create a stem and leaf. But we created by each value is represented by 2 different sets of digits. And the left group is called the stem, and the right group, a single digit, is called the leaf. And there's no rule for the number of digits to be included in the stem. Usually the single digit is the leaf and the remaining digits are in the stem. So let's take a look at some data. 20 students in a geology class were asked how many college credits they had earned. Here's the responses given here. Choose the correct stem and leaf. So the first thing that makes it easier is to put the data in order. I think it makes it easier for me to see the data values. And so I noticed there's one student who has 21 credits, one has 23, one has 25. 2 of them have 26, so I'm going to have a leaf for each of those, so I need 2 6s. And if I look over here, I've got, now here's how you put the numbers back together. The first student represented on the left side here is a 21, which I see in my data, and then a 23, and then a 25, and then I see 2 students who have 26 credits, and I see that in my data. If I look on the right side, they've not repeated when there was more than one student that had that many credits, and you have to have a leaf for each value in the data set, so there has to be 20. And so the correct answer here is going to be the one on the left side rather. A circle graph, which is also known as a pie chart, are used to compare parts of one or more components of the whole to the whole. So here's an example. 800 people attended a Ringling Brothers and Barnum and Bailey circus, and they were asked to indicate their favorite performance. The circle graph shows the percentage of people who answered all the different categories, and we take a look at it here. So we see 38% said they liked tigers best, 26% liked elephants, and so forth. We want to determine the number of people who answered in each category. And we're going to do that. We have a total of 800 people. And we're going to do that by representing the proportion or the percentage in each category by 800. So instead of saying 38%, we want to know how many people selected tigers. And there's the percents. And so in the table here, we're going to take 0.38 times the 800 and we get 304. For elephants, we take 0.26 times 800 and so forth. So here's the number of people in each of the categories, and it totals up to the 800 that we started with. And again, we can list that down here. And here's another one. The cost to attend a public university in a recent year was $14,967. The circle graph to the right shows the percentage of that cost for 4 categories: tuition and fees, room, board, and computer costs. Determine the cost in dollars for each category. So what you're going to do is you're going to take the percentage as a decimal and multiply it by the total cost to get the category amount that's represented by that particular category. So for tuition and fees, we're going to take 31.2%, take it as a decimal point, 312 multiplied by 14,967, and I come up with 4669.7. I'm going to carry all the decimals for right now, and I'll show you why in a minute. And then for the room, I'm going to take 39.5% of the total cost. And for the board, I'm going to take 22.8%. And then finally for computer costs, it's 6.5%. And the reason I kept all the decimals is when we add those 4 figures up, we should come up with the total cost that we started with as a nice check. And in fact, you do. A sample of 600 people was asked which one automobile accessory they would prefer to have on a family road trip. The circle graph shows the percentage of respondents who answered Bluetooth, DVD player, extra cup holders, roof rack, and other. And we see the most popular one was 29% was Bluetooth, just ahead of the DVD player. How many people preferred Bluetooth? So we're going to calculate 29% of the total, which was 600 people, and we come up with 174 people.